Hello, everyone. Thank you for coming. I know that this is the time of day where you would really like to be outside living life. But I appreciate you taking the time to be with me here today as I talk about DataEval, an end-to-end data analysis tool for machine learning development. I am Haley Green. This tool is something that we've designed at Aria, the company that I work at, supported here by my coworkers and my founder, basic fundraise. But I'm here today to talk about this really cool tool that I believe can help in machine learning development. So going through that whole cycle. There we go. All right. So a little bit about how I'm going to structure this tutorial. First, I'm going to do some, PowerPoint slides going over the motivation. So a little bit as to why you should care, what DataEval essentially is, and then kind of show you how you can navigate the documentation, because I do think one of the strong points of DataEval is that it's very well documented. It's a great resource. And then I'm going to go into the Google Colab notebooks. And I shared a Drive link. It's on the conference session site. It was shared out in an email earlier this morning. But I will also pause before we kind of switch into that, just to make sure if you want to follow along which of the notebooks you should be looking at, because I did restructure them a little, knowing that people probably don't want to have the cognitive burden of having to navigate a bunch of different workflows at this point, or notebooks at this point. So getting into the motivation. Data is fundamental to learning and machine learning and AI tasks. I'm not sure if I need to convince you of this, but I'm going to go over the spiel. So you have operational risks. So with flawed training data, that can lead to unreliable model behavior. There are resource constraints. So in operational environments, you can't just increase the volume of data. It's sometimes technically or logistically impossible. You have your validation uncertainty, and in that case, determining if a data set is sufficient for a specific task remains a significant hurdle due to lack of formal benchmarks. And then you have a methodological complexity. So there are so many tests out there that you can run, and a lot of machine learning development is something that you intuitively get better at the more you interact with these tools and things. So if you're just starting out, especially, it's hard to know what you should be doing. Even if you're an expert and maybe you're looking at a different domain or a different task, it's hard to know what to do. You also have your nitty gritty real world challenges. So you've got class and balance. Ideally you get a data set that's evenly distributed, but we all know that that's not necessarily the case in operation. You have outliers, you have underlying correlations, duplicate samples, underrepresented samples, irrelevant samples, covariate shift, and label error. So these are all, and these are not all of the things, but these are some of the things that can make modeling challenging. So with all this, you have this question essentially of how can you determine whether your data set is good enough for a specific use case before committing significant time and resources to the training process? And I don't know if you've heard this term before or this saying before, but I feel like what gets thrown around a lot is if you put garbage in, you get garbage out. So how can you kind of ensure that your data set is not garbage before you devote a lot of resources to it? And this is where I introduce you to DataEval. So our aim is to bridge the gap between raw data collection and model performance by ensuring data set integrity before deployment. So not waiting until the end before you're like, oh no, this is not it. Mitigate common operational hurdles, including sensor noise, class imbalances, and insufficient coverage of edge case conditions. We also aim to provide a suite of metrics for performance estimation, bias analysis, and automated data set cleansing. and then identify critical data distribution shifts and potential failure points from initial collection through active operational monitoring. So summarizing all of that to say DataEval is a tool to support users from data collection through operational monitoring. So we want to help you along that entire ML lifecycle. Key features include metadata features. There are model-specific metrics, performance optimization, responsive metrics, robust testing, post-deployment monitoring, drift detection, and complete shift analysis. So that might mean something to you. It might not. I'm going to go over these different features in a little bit more detail during the notebooks. And I think I'm one of those people that terms make a lot more sense to me when I'm seeing them in action. And so I'm hoping maybe that could be the same for you. Getting into the documentation itself. So if you're already in the drive, you're like already in it, you can activate this and kind of see what the documentation looks like itself. This is how it's framed or kind of structured, and I'm going to drill down into each of these just so you can see, at a high level, when I release you out into the world and you want to look at DataEval, you can know how to navigate the documentation. We start with the getting started. And so in this section, it covers installation. So we support pip install. There's also Conda installation if you want to use that. There's also some great documentation on how to prepare your data set. So there are two usage patterns depending on which submodules you're using. So there's we have DataEval core, which provides stateless functions that operate directly on NumPy arrays. And then there's some other modules or submodules that provide stateful evaluator classes that require a mate compliant data set. And before you ask, what is a mate compliant data set? I shall tell you. So MATE stands for Modular AI Trustworthy Engineering. It's a standardized protocol for passing data between AI models and evaluation tools. And it essentially is saying that you need to have images, or your data set needs to have images, labels and targets, metadata, and embeddings. And DataEval provides instruction on how to wrap some of this more standard format. So if you have like a torch vision data set or a Hugging Face data set, there are wrappers to help you kind of cross between those. And we won't be going over that today, but if you're interested in learning more, you can check out the documentation. Next up, we have tutorials. So there's a list of, and this is outside of the ones that I'm going to be giving you today. DataEval also has collab tutorials on subjects from introduction to data cleaning to monitoring categories, so like monitoring shifts and operational data. And so some of the tutorials today kind of borrow from those, but if you're interested in learning more or if something in the tutorials isn't covered, I recommend you check out these. They're pretty cool and a lot of love went into making them. We also have explanations. And so there are, if you're really into theory and you like to know the math behind the things that are being done, the papers that are being cited, like the real fun details about the calculations and functions that we're running, we have very detailed explanations in the documentation. So there's data integrity, embeddings, clustering, dataset bias and coverage, performance limits, distribution shifts, divergence, and then acting on results. So if you're sitting here today and you're wondering, what are the actual statistical measures that are being used in divergence, check it out. You will be delighted, I assure you. And we also have how-to guides. So these guides walk you from configuration to data engineering to model development to monitoring, so kind of guiding you through that workflow. You might be wondering, how are the tutorials different from the how-to guides? Because we have both in the documentation. And I actually asked one of my coworkers about this, and he said that The tutorials are designed to really teach you something. So kind of walk you through the actual concept and understanding of what you're doing. The how-to guide is more, I mean, you're still obviously learning, but the how-to guide is more targeted at, I have a specific use case and I need to know how to do it with DataEval. So how do I clean my data? Tell me how to do it. But it's also structured in that kind of work notebook formulation. And then one of my favorite areas is the reference section. I think that DataEval does a really great job of kind of explaining the different submodules and classes that it uses and how you can leverage them on your own. So we do get you started with kind of a basic overview, but it makes it very easy for you to take and apply to your own use case and see how you can leverage these tools these features for yourself. And so you have the submodules category, which kind of lists out these different components. Let's say that I want to look into like the quality submodule. And so I can look into that. I see that the related classes within DataEval quality are duplicates and outliers. If I want to know more about duplicates, I can enter that. And then it shows you like what are the parameters that it's taking in, what are the features that the potential features that you can use, and then it gives like a brief example of maybe how you would use that. And so I think that that's a really cool component. And then we also have the roles guide. So I think one of the talks yesterday mentioned that it's very easy to kind of lose yourself in this process. So am I a testing and evaluation engineer? Am I a machine learning scientist? Am I a data scientist? There's a lot of interchangeability between these roles. And I think sometimes you can get lost trying to categorize yourself and not see the big picture. But at the same time, I do think that these roles can help kind of guide you on what is maybe important to you in your work or in your workflow. So this isn't to say that, a testing and evaluation engineer won't ever care about model development, but if you're interested in a particular area, these might be of interest to you. And there's more details on that within the documentation. So I would say that the machine learning workflow or lifecycle is not exactly linear. So obviously, you're not going to be able to deploy a model if you haven't built it yet, or you can't train a model if you don't have data. But after you get through that kind of generic sequential workflow, there is a lot of iteration and going back and forth within that pipeline. So, the information that you're getting from the model development is going to maybe inform or cause you to update your objectives or reform your problem. So there's a lot of kind of movement between the different steps, so to speak, that takes something that's linear at the overarching level, but makes it a little bit more interactive. And I think that DataEval does a great job of kind of recognizing that and allowing users to kind of make use of that. And so you've got your, items of interest to maybe a machine learning engineer, and then your data scientist, which again, no way goes to say that as a data scientist, you don't care about deployment, but just for generally speaking. So we're going to dive a little bit into the hands-on workflow now. I will pause for this. So, well, let me say first that this is essentially how I'm framing it. So there's 6 steps. Originally, it was 6 notebooks. And if you go into the drive, there's a tutorials folder that has the 6 original notebooks. I realized this morning as I was kind of running through things for the final time, 6 notebooks is just a lot to navigate, especially since Google Drive doesn't make it easy for you to copy and paste a view-only notebook. So there's one notebook now. It's called DataEval tutorial. It's in the main Drive folder. If you can access that, if you want to play along or code along, I recommend you access that. So this is what it should look like. This is the one that you want. And then, and to take a step back, if you're running this with if you're going alongside, I also recommend running this notebook. So I lied, there are 2 notebooks that you would need. This one is just to get this cache folder into your own Drive account so that you can kind of pull from that. I realized when I was running this that, so we're going to be running on CPU, and the data set isn't particularly large, but I also recognize that waiting a couple of minutes for a Colab note or a Colab cell to run isn't the best. So I have pre-run some of the more compute heavy steps and it'll just load them. If you don't have this cache folder, it will run live. You just might get stuck waiting on the sufficiency calculation or the duplicates calculation. But if you run this setup notebook, and so you should be able to just connect. So if you connect, and then run all, you should be able to get that cache folder into your Drive. If you don't want to run the cell, you can also copy and paste, but you're going to have to do that. Or you can wait and run it live and see what it's like in real time. Does anyone have any questions or is anyone having any trouble? It's also okay if you want to just watch.
Just curious, is it creating some sort of environment, like Python environment, or is it exploring everything and going away?
So it's just the cache is just a bunch of pickle files. And we will be installing DataEval. And so this was one of the issues with all the notebooks is that when I ran it locally, the installations would kind of persist across the different notebooks. But when I was running it in Colab, I can only have, I burned through my usage. And then I could only run one notebook at a time. So I would have to disconnect the runtime and then connect again, install everything, disconnect, connect again, install everything. And it's only a minute for the installations, but nobody has time for that. So I combine them all into one, and you're going to see as we go through here, you might be wondering why is she importing this again? It's already been imported, or why are we loading the Sci-Fi 10 data set again? And that's just because I wanted to keep the structure pretty similar to the original separate notebooks, and it didn't hurt anything. And then, so again, I talked about this a little bit earlier. A question to ask for outliers versus edge case is, asking yourself the question of, is this something that I would see in operation? It's a little bit more challenging in a data set like this that has so many different, it's kind of harder to pinpoint exactly operation of this. But if you were, maybe detecting ships, it might be easier to kind of ask yourself, is this picture of a ship in the desert something that I will see in operation? And then getting into coverage. So outlier detection in the cluster space finds images that are kind of far from those clusters. You can also ask the complementary question of, are there regions that aren't that aren't part of the feature space or that are underrepresented. So things that like should be clusters. And so you can run that. And so there are essentially 500 images that it detected for being uncovered. You can preview those. And so what you can kind of, or the thought process that you can have from this, or the kind of mindset that you can have is images that appear in both lists need the most attention. They are both unusual and unrepresented or underrepresented. The recommended, and so then the recommended handling order is like if they're both flagged, you can initially treat it as a coverage gap. And then if you can collect more similar images, maybe do that. If not, you could potentially remove. If it's coverage only, you could potentially collect more data of this type. And then if it's outlier only, maybe examine it, remove it if it's relevant, or remove it if it's irrelevant, and then keep it if it's about case. Yes.
So by the course of so like
Yeah, you can. So that can be one of the strategies for kind of making use of a limited data set is augmentation. And I'll show it at the end, but DataEval is part of like a greater family of kind of data evaluation and like model development tools. So there are like a whole suite of other tools that can help you with like generating image perturbations and, looking for robustness and all kinds of things, which I can share after. Yes, so these are images that were flagged as being both coverage or uncovered and an outlier. Right. So that is the end of what would have been notebook 4. Oh, sorry, notebook 3. Let's not get ahead of ourselves. Now we're getting into the classification feasibility. So we are going to be looking at the Bayes error rate to assess classification feasibility. If you're unfamiliar, the Bayes error rate essentially quantifies the irreducible error or the theoretical minimum error to any classifier that can achieve a minimum error any classifier can achieve on a given data set. It might be, I will give the disclaimer that the Bayes error isn't just like, there are a lot of things that can go into how a model is going to perform. So there's like different, like there are different things that you can do in different performance scenarios that you can see. So the bear isn't like this sticker that you can slap on and say, bear said no, this is not going to work. And bear said yes, this is going to work. So there's a lot of other context that needs to be taken in, but this can be a good starting point just to see, what is like the minimum error that this got, or like what is the minimum error that I can expect. Okay. So we're going to be loading the cache embeddings from the previous start. And then we're going to be breaking this down into, just to make it a little more interesting, we're going to break it down from the 10 classes into 3 that are kind of visually similar. So we're going to be looking at cats, deer, and dogs, just because those are so visually similar, especially in this data set that everything is visually similar. At least to men's or my mother's eyes. So we've got our 3,000 images that are embedded, and then we want to evaluate the Bayes error rate. And so let's say for the sake of this example, our accuracy requirement is 85%. And so that's like our limit that we want. We can see that, the minimum achievable accuracy is 76%, which is not 85%. And so the accuracy requirement is not met. And then what you can do from that is you can think about, and so this goes back into how, this process isn't necessarily like linear. Like once you're done with the scope and the objectives doesn't mean you're done for good. So this could indicate that maybe you want to reformulate the problem. So instead of saying, I want to know if it's a cat, a deer, or a dog, you can say, it's not that important to me to be able to distinguish between all three. Maybe I want to know if it's a cat or if it's not a cat, because deer and dog are even more similar. And so maybe that's not as important to you in your problem. And so what you can do is you can kind of combine that into like a binary problem. So either cat or not cat, and then you can run it again. And we're still not getting the accuracy that we want. And this also shows that, just because you reformulate the problem doesn't necessarily mean that it's going to, fix everything. So there might be other areas that you need to reevaluate in order to get the accuracy that you want. Or maybe the accuracy that you want is not necessarily possible given the constraints that you have. So this could indicate that you might need to go back and think about your problem a little bit more, or like the data that you're using or the model that you're using. But 80% is still, so kind of combining the two classes still did increase that prediction a little bit. Any questions on that? Cool. All right. We've got two more notebooks. And so those are going to be the sufficiency and the monitoring. So this is getting into our our model performance and our deployment evaluation. So in the sufficiency, this next part of the tutorial, we're going to be talking about sufficiency. And so it's knowing that the data collection process can be expensive for a number of reasons. You need to ask, or you might need to ask yourself, if I collect twice as much data, will my model improve enough to be worth it? So it's a terrible thing for you to go and collect all this data and spend all of this money and all of these resources and then find out that it was never possible for you to achieve the performance that you wanted to achieve. And so, like Bear, this isn't like a guarantee, but it can give you kind of like a ballpark idea, before you start burning through all those resources. And so sufficiency, as I mentioned, is good if you have like a preliminary data set and you want to kind of project out what that performance might be. Just going through our setup, loading the data set, and then I'm loading the pre-trained model. So this is all, sorry, so I can go back a little bit. So we're going to be using that ResNet 18 pre-trained on the ImageNet data, and then using this as the backbone, and then swapping out. So we only want to train on the, so we're going to swap that out and then train on that last layer to be this sidebar 10 images. Right, so running that. And then we want to, okay. So the sufficiency, so it has these two strategy protocols, which is really nice. And so this keeps some of your choices separate from the sufficiency logic itself. So it allows you to kind of go back through and make edits as needed. So we have our training strategy and our evaluation strategy. We kind of established this here in the tutorial. You can customize them based on your use case. And then there's also the reset strategy. which is a function that resets the model weights between runs so that each sub-step starts from a fresh initialization. So running those, we got our training strategy, motivation strategy. And then we want to configure and run sufficiency. So in the sufficiency configuration bundles the different strategies with two hyperparameters of interest. So you can have the runs. So how many independent training runs to average at each data set size. And then your sub-steps. So how many points along the learning curve to evaluate. And these are logarithmically spaced from a small fraction of the data up to the full training set. Efficiency, the evaluation. And then we want to analyze the results. So the output here is the true positive rate at 0.5 fixed, false positive rate, accuracy, and the area under the curve. And so these are kind of the different metrics or the different results that you can see. These are the steps. So we were using like 2,500 samples in our sufficiency curve. You can have more, of course, but it just increases your compute time. But so this is just showing what that projected performance is. You can also project it out. So these are like projections forward based off of what information was obtained initially here. And so you can say, once we start getting out to like 10,000 samples, what is this accuracy that we can potentially get, and keep going from there. And so then you can plot this learning curve to show the observed performance alongside the fitted extrapolation. And so you can kind of see like where that kind of peak or like the trade-off is. So you can have like the like at what points does it kind of start to level off? If you have, if the projected like maximum, especially so you have your area under the curve, accuracy, true positive. Like if that projected accuracy is kind of tapering off around like 60%, having like, 80,000 samples isn't necessarily going to make that much of a difference. And you can kind of work backwards from that. So using the inverse projection, you can say, well, if my goal is to have like 40 or 70% accuracy or 80% accuracy, how many samples or how many data points do I need? And so it will kind of work that back for you. And then this -1 value is essentially indicating that the sample is projected to be unachievable by scaling data alone. So you can like keep adding or increasing your percentage, but this plot is telling you that it's not going to happen. Yeah. So that is essentially how you would use sufficiency. All right. Now we're into the last one, the home stretch. Monitoring drift. So this is when you have, you have cleaned your data, you have evaluated your data, you've, trained your model, checked all the boxes, done all the things, and now your model is out in the world living its best life. Why would you continue to pay attention to it after that? You may ask. And I say, please continue to pay attention to it after it's released into the world. So when a model is deployed, the data it receives in production can and generally will shift away from the distribution that it was trained on. This is called distributional drift, and it is, a cause of silent model degradation in production. And so DataEval has tools that will help you to kind of monitor that drift and check to make sure that your incoming or your model is still working with the data that it's being given, or like the incoming data is matched to the data that it was trained on, or not drifted significantly. So doing some of our repeat things again and again and again. We're still leveraging embeddings for this. And so now we are loading, the training data set has already been loaded, but we are also loading the operational data set, which for this particular example is just a sample of the CIFAR 10 tests data set, because I do not have operational data of this data set because it's already been collected and is no longer being collected. But in theory, you could use your own incoming data. And then training embeddings. And so we want to then fit to the drift detector, or fit the detector on the training embeddings. And then we get to the point where we're testing for drift. So first we want to run it on just our clean operational data. So this is, let's say, the operational data that we're using for this example is like what you've been getting in. So this is what you're running, you're testing. And you're checking to see if it's drifted. So you can run that. And so you can actually output, values of interest, which I'll show in the next step. But as we would hopefully expect, since the test data is, the CIFAR test data is like part of the data set, the drift is not marginally different from the training data, or significantly different from the training data. So it's triggering as being as not have drifted. But in order to kind of show what it might look like in a case where it is drifted, we'll add we'll apply a perturbation to the operational images just to see, what a flag would look like. So we're going to add some Gaussian noise to the images, adding more noise to the images. And then running that. So these are some of the actual result or outputs that you can get. So we it's maximum mean discrepancy squared is one of the metrics that we use in this, or one of the statistics that we use in this. And so the distance is 0.4. Our threshold was not that. And then so a very, very small p-value can indicate that drift has occurred. And so we're seeing now that the data set, or the operational data, has in fact drifted from what it was trained on, or what the model was trained on. And then beyond image level drift, it's also important to check whether the class distribution has changed. And so a model trained on a balanced data set may underperform in production if certain classes appear far more frequently or far less frequently than during training. And so label parity is one of the ways that we use to kind of, or one of the ways that we evaluate whether that that distribution shifted. So through running that, we can see that the output here, and we're just running this on the clean operational data or the clean operational data. We're seeing a label parity of 0.6. So anything that's close, it's like evaluable. So things that are close to 1 and or typically indicate that the classes the class distribution has not changed. If it's under 0.05, it can indicate that you might need to reevaluate. And so one of the things to mention is that when checking for drift, if you run this and you get a flag that something is drifted, it's not like a knee-jerk reaction like drift alert, shut everything down, retrain. It's kind of like a persistent, like if you see like large segments of drift or like patterns, I guess, emerging, and that's when you might need to reevaluate. And this tool is essentially to help you kind of make that process smoother for as a user. Yeah. So that's just going through how we would leverage the drift tool, how we look at label parity, and that is, essentially just a walkthrough of, data you got from data loading to model monitoring. And then, as I mentioned before, so here's some. Struggling. So here are some resources. So this is the DataEval documentation if you want it, and it's like a link if you want to access. And this slide deck is also part of the Drive folder. Our GitLab, or GitHub, and then so the tools that I was mentioning earlier, like DataEval is funded by like CEO. It's part of this JADIC tool base where there's a lot of different tools that are there designed to help you make the data evaluation and model development process easier, more transparent, and like more sure, I guess. Yeah. Any questions? Comments, concerns? Sorry, I'm 20 minutes early. Yeah, I think that, at least for me, so prior to working at ARIA, I hadn't done a lot of image classification tasks. My work was in like classifying like physiology and like time series data. And I think that getting to work or like getting to use this in like my day-to-day workflows really helped me to understand how to kind of apply these skills across different tasks and different domains. So like looking for like areas of bias, things to look out for when you're cleaning your data, and these like some of the concepts. And that's where I really think the documentation, because it explains the theory and the ideas behind like data cleaning and looking at drift and these different things, which yes, the tool works mostly in like image classification or object detection scope, but you can kind of take that and transfer it to other areas. Yeah. Anything else?
So I have a quick question for everybody in this room. Those of you that actually currently work on data science projects and things like that, like what are things that you struggle with and you would like to see? So like this is a government funded project, it's open source. And so we would love feedback. We want to implement those things that are most helpful and would benefit you. That's the end goal of this. So, yes.
So I've got one that many times people come to me and they machine learning done and they say they have a lot of data. And a way to like this is great for me as a data scientist to understand that the data is not sufficient. But how do I tell them and convince them that like what they're trying to do with their data set data is not adequate and convince them that like, okay, this is what they need.
Yeah, so okay, so there are so what Haley showed today isn't all of the tools inside DataEval, so there are more additional tools in there. So right, so like I think about that is whenever somebody comes with like a whole lot of data, right? The very first thing is like what kind of quality is this data, right? But then two is right, like for your problem, right? So that's where it's like the BER case comes in, right? Is like trying to define a scope for the problem of like, well, what is your accuracy requirement? What is your production kind of requirement, right? Like, what do you need to see in order for you to be able to take this, right? Because then if you can have that, if you can get like a hard line from them, right there, then that's like where like sufficiency, BR, and there's a few other tools, so like UAP, and they can be able to point a line on a graph that says like, hey, like no matter what, like you can't reach that line given this space or this scope, or regardless of the amount of data you might have, right? I mean, then you can also like run back through with like the outliers and the duplicates thing like that and be like, right, you might have a lot of data right now, but it's not actually a lot of good data, right? So if we actually shrink this down to like the usable amount of data, right, then you only got about this much data. And right, running sufficiency says like, hey, like you're actually going to need about 10 times as much data as you have. It's of this good quality data, not, just of any kind of data, but this quality data kind of thing.
Like I get how all these things will tell me that, but
Yeah.
communicating that to somebody who is not that data literate is challenging.
So yeah, so and that's where it's like really, I think like, right, if you can get to like a hard line from them that says, right, like I need a 90% accuracy for this, or I need this kind of a bar, right? Then you can show plots. And I think that's like visually, I think that's going to be the best thing. It's just like projecting out data, right? Like, or showing like what's the current amount of data, right? This is all the better that you can do, and this is the target you're trying to target. So either, right, we need to move to a different model, right, or we need to move to different data with things like that.
Oh, yeah, even getting like what's their accuracy bound is sometimes tough.
Yeah.
Yeah, so a lot of times like the translation task is figuring out, okay, in this, you're making a system, how many failures are okay for you, or what percentage of the time do you need to be right? Some sort of mapping that's operational. Unfortunately, the task then is mapping it back to like an accuracy, or that's why I guess you showed a bunch of different things, right? Like false positive rate at a particular true positive, or that's usually the one that we end up using in those cases. They at least have a sense of like how many you can figure out from their requirements how many false positives they can tolerate at a particular true positive or something like that. And then go to the curve or go to the this is the absolute best you can do with what you gave me. And then map that to whatever their thing is. That could be adequate. Sometimes it's not, right? That's usually the case we have. You're like, no, not with this. Maybe not at all. I guess Ryan's model's good, right? Like sometimes it's like a question of how good can you do with the data that's actually usable, the data you give us. And a lot of times it's because, and that's without labels. That's sort of a label dependent task. There are some tools that we didn't get a chance to show label quality. That makes it even, unfortunately.
Well, but also bouncing off of that, I think especially communicating information to maybe like audiences that are maybe outside the domain, I think visuals are great. So like showing them like that sufficiency curve, like seeing that it plateaus there and it's not going to go up again. I think that is helpful to someone that might not understand, like, no, this is as good as it gets. Like, look at it.
Yeah. Sometimes we'll use that gets used in sort of a financial thing of like, where do you be developing your model? Could you? So we didn't do it in this one, but you can run it for multiple models and multiple sets of data. So we'll sort of say, given your performance requirement, either invest in building better models or invest in gathering data. And here's the trade-off. But yeah, I think it's in one of the tutorials in the DataEval tutorials. It's not in this one.
So this right here, so this is like the initial page to the roles guide, which talks about, different roles, but this is kind of written from like more of like a management perspective kind of thing of like, right, like this is try to. Oh, no, don't-
Yeah.
Oh, I'm sorry.
So the idea behind this like kind of initial page, right, going down like data eval and AI projects is trying to help like, right, like there's a ton of questions that we kind of came up with and stuff that's like something that you would want to know or ask from like a project management perspective, right? Of like, and then going on down further is it's trying to help you figure out how to tie data eval stuff into those questions and into the things that like people really care about, right? Because like, right, like knowing that I have 2,000 outliers, like, right, somebody that, right, the manager doesn't care how many outliers there are, right? That doesn't tell him anything that is usable from a business perspective. So that is what this page is. So hopefully that will be helpful. But yeah, so it kind of goes back to some of the stuff that we said, right? Just so the idea behind all this is just it tries to tie specific techniques and metrics that we have in there to specific questions that you would want to know.
Thank you so much for the presentation. It was great. I'm wondering if I could use data eval for non-classification problems. And for example, I'm really interested in forecasting. Could I use weather variable or raster data sets? And will that be able to? Is it only for classification? I guess that's my first.
No, it is not only for computation.
Testing.
Yeah, I'm not sure that we have tried that. That is,
Yeah, we haven't done like for time series forecasting. That's
Yeah.
interesting. Yeah.
so yeah, so specifically the government wanted it for computer vision, which is why it's heavily computer vision and stuff. So some of the tools in there are going to require. I mean, but you could. Yeah. Like if you could generate labels for your data in the way that would make sense, right? Essentially, like it doesn't care whether it's like a 3 by 32 by 32 array or like a 1 by 500 or whatever, right? Like it doesn't actually know what an image is, right? So it would work on anything that we could just stack in as a numerical array. So it should, but I haven't tested that.
And as a follow-up, so I can add like multi-dimensional
Yeah.
sensors, like different bands of images and
Oh yeah.
Yeah.
So this works. So satellite images are often 12 or 13 bands of 512 by 512 images kind of things. So this will run any number of channels, essentially any size of images.
IR and hyperspectral.
what about combining different satellite sources? Or will it account for inconsistent pixel or consistent
That's an interesting
resolutions?
question.
So a bunch of the tools we have methods that try to infer essentially like resolution and then unify the resolution and run everything all the time so that it can work on different data sets and on different sets.
Yeah, but like a fused data set, I don't know. It's interesting. It might be.
So it is designed to work on these data set.
Anything else?